Hi. So today we are going to learn about solving systems of inequalities, just like before we learned about solving systems of equations, right? Except before, when you solve a system of equation, you get one answer, and here you're going to get a whole area of answers because we know from graphing our inequalities that inequalities have areas as solutions, not just points, one point, right? So let's graph this system. Right, and our first step is to graph the inequalities, and we're going to graph them separately. So I'm going to say this is my purple and this is my blue. So anytime you see purple, it's referring to the first one. And it's not in y equals mx plus b, so let's put it there. We have negative x plus y greater than negative 1. So I'm going to move my x over, plus x. So y is greater than x minus 1. Okay, so this is my y-intercept. My negative 1, there's a point there, and then my rise over run is 1 over 1 because that 1 is imaginary, so up 1 over 1, up 1 over 1, and then it's not greater than or equal to, so it's my dashed line. We have to put our dashed line, so right there, okay, and then it's greater than, so we shade up, so all of this. Okay, make sure you know what that looks like. If you have colored pencils, this looks a lot nicer. But I don't have colored pencils, so. Okay, so let's do our other equation. We have x plus y greater than 3. So let's solve for y. Let's get rid of that x. Y is greater than negative x plus 3. Alright, so my y-intercept is 3. So I'm going to come up here to 3. And I'm going to go down 1, right 1. Down 1, right 1. Okay, once again, this is not or equal to, so it's not shaded. Okay, and it's greater than, so it's everything above. Oops, I need this one. My pen. Alright, so you see this area right here, okay, but not including the points on the line, right, because it's not or equal to. So all of those points in that area is my solution. And so the overlapping shade is the solution. For step 3, it says check by plugging in a point and seeing that they both work. So that means that any point you pick in this shaded area with both shades is going to be a solution, and it should have a true statement when you plug it back into your equations. So I'm going to try to pick an easy point, right? I can't pick the easiest because 0, 0 is not in my shaded area, but I can pick 2, 2, right? So I'm going to plug in 2 for x and y and see what I get. And it should be a true statement. So if I plug in 2 for y, is that greater than 2 minus 1? Well, yes, right? Because 2 minus 1 is just 1. So that works. Is 2 greater than negative 2 plus 3? Well, 2 is greater than negative 2 plus 3 is 1. So that works too. So that means that this shaded region does work, and it is, we did it the right way. Okay? We shaded the right areas, and we're good. So we can move on to the next one. Okay? This is just another example. So you have more than one, right? My top one is still going to be purple, and my bottom one is still going to be blue. I have to graph both inequalities. So I'm actually going to do something right here. I'm going to alter this graph. I'm going to say that that's like 4. So I don't have it in y equals mx plus b again, so I need to put it there. So y plus 3x less than or equal to 4. So let's move that 3x over. So y is less than or equal to negative 3x plus 4. So let's graph that. Right, let's go up 4. It's negative 3 is our slope, so down 3 over 1. 1, 2, 3. To the right 1. That's enough, right? So let's draw our line. It is or equal to. So we have a solid line. And it's not perfect, but it's there. So it is less than, so it should be down, right? But sometimes if our line is almost straight up and down, we don't know exactly what is down, right? Sometimes. So let's pick a point and test and see if our shading does go that way. And if it does, then we'll shade that way. So let's pick our easy point, 0, 0. See if that's in our shading. It should be, kind of, depending on what you're thinking, right? So let's plug in 0, and I'm just going to talk through it. So negative 3 times 0 is 0. So that's my x. So I actually have 0 less than or equal to 4. And 0 is less than or equal to 4. So my shading should be this way. Okay? And again, make sure you have a good idea what that area is. And we'll move on to the next one. So, y minus 3 greater than 2x. We want y is greater than something, so let's get rid of that 3. So y is greater than 2x plus 3. So I can graph this. I know how to graph this, right? So I go up to 3. Okay? And then I go to my slope, right? Up 2 over 1. So up 2 over 1. Or down to minus 1. Okay, this is still not or equal to, so this one has dashed line. And that's okay. And it is greater than. So we are shading above the line. So we are shading all right here. Okay, so there is some points that aren't overlapping, but a lot of it is according to what we see. So let's pick a point, right? An easy point, because this is our supposed shading. And you can actually include this line. So I should have moved it over to include that line, right? It doesn't actually hit the dotted line, but it does hit the shaded line. So any points in there. So I can pick, I don't know, -1 or -2, 2. All right, we picked 2, 2 last time. Let's pick -2, 2 this time. And I'm going to plug it in and make sure it works. So my -2 is x. So -3 times -2 plus 4. Is that less than or equal to 2? Well, -3 times -2 is 6, right? Negative times a negative is positive. 3 times 2 is 6. So 6 plus 4. And then 6 plus 4 is 10. So 2 is less than or equal to 10. That works. Okay. Again, 2 is 2 greater than 2 times -2 plus 3. Well, 2 times -2 is -4 plus 3. So 2 is greater than -1. So that works. So my shaded region is correct again. Okay, and that's a good thing. We want it to be right. Alright, so this is what you're going to do. You graph both lines, do the shading for both lines when you graph it, and then see the overlapping spot. That should be your solution. Test a point. Okay, make sure it works for both of them. You have to plug it into both of them every time, because it might work for one and not the other. And that means you did something wrong. And so your goal for the try these is to graph 3 of them. Again, using graph paper is an option. If you want to do it on graph paper, that's good. If you don't have graph paper, that's okay. Use different colors if you can, so you can definitely distinguish which one's which. And have fun.